Shed A union C complement intersection B in the Venn diagram below. Now, before you start dealing with these particular problems, you have to understand the terms like union, intersection, complement. So let's first deal with this, and then we're going to solve this particular problem. So let's say we have the universal set, and this universal set has got elements. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you look at this universal set, let's say set A is equal to 1, 2, 3, 4, 5, 6, and set B is equal to 4, 5, 6, 7, 8. Okay. So when you look at this particular scenario, you have two sets, set A and set B, in this universal set. This symbol is the symbol for union. For example, you can have something like A union B. What it means is that you're dealing with members that are in set A or in set B, or which are in both sets. In other words, it is about combining all the members of set A and set B, all the elements of set A and set B. So if you are asked to write the elements of set A union B, what you're going to say is that this is going to be all the elements in set A and all the elements in set B. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is A union B. You're not going to include 9 and 10 because these are not part of either set A or set B. So this is what we mean when we say union. Now, intersection, this is the symbol, intersection. So we can say A intersection B. This means the elements that are in A and B. In other words, the elements that are common in A and in B. For example, if you are to list down the elements of set A intersection B, you're going to look at the members of the elements of set A, 1, 2, 3, 4, 5, 6. And then in set B, you have 4, 5, 6, 7, 8. So what is common here between the two sets? You're going to see that here you have 1 to 3, which are not here. But you have 4 and 5, which are here. And 6 included, because 7 and 8 are not part of set A. So we can safely say that the elements 4, 5, and 6 are the ones which are forming this intersection, because we're talking about the elements that are both in set A and set B. They are in set A and in set B. They are common in set A and in set B. So that's how we try to deal with problems dealing with union or intersection. But the third point which you have to understand, and that is complement. So complement is written as this is complement. So when you have the symbol for a set like set A and you have this symbol on top, this is called complement. So what does it really mean? Well, it's very simple. It simply means that you are dealing with elements that are not in this set. So, for example, when we say a complement, it means that we are looking for elements that are not in this set. You getting the point? So, for example, when we use the same example here, let's say we want to find a complement. So list a complement. So that means that we are not going to include all the elements of set A. So if we exclude 1, 2, 3, 4, 5, 6, the elements that are in set A, because complement means that we are dealing with the elements that are not in this set. So we exclude 1, 2, 3, 4, 5, 6. Then for us to list the elements of a complement, we're going to start from 7, right? So we're going to have 7, 8, 9, 10. So this is a complement. So just make sure that you are familiar with these terms: union, intersection, and also complement. Now, you can also try to understand phrases like A union B, and then you have complement. So in this case, when you're talking about A union B complement, it means when you have A union B, everything that is in A union B shouldn't be included, because that's what complement means. So in this case, when you're talking about A union B, this is A union B here. So we have A union B. So A union B complement means that what is in A union B shouldn't be included. And if that is the case, then you can clearly see that all these numbers here are not to be included when you're talking about A union B complement. So the only numbers that we are going to get are 9 and 10. So 9 and 10 form this complement, A union B complement, right? In the same way, you can say A intersection B complement. So when you are talking about A intersection B complement, this is intersection 4, 5, 6. These are the elements that are making up this intersection, A intersection B. Which means that when you are talking about A intersection B complement, these values shouldn't be included. You shouldn't include them in this particular listing. So it simply means that we're going to exclude these values. And so we're going to have 1, 2, 3, and then 4, 5, and 6 shouldn't be included. So we're going to go to 7, 8, 9, and 10. So this is how you actually deal with union, intersection, and also the complement problems. So now let's go back to our question. Before we look at the question, you have to understand that when we are illustrating information like this in the Venn diagram, we have to be very careful, because when you have two sets like this, you know that you have set A and set B. So in this case, when you're talking about union, you are talking about both set A and set B. Whatever that is in set A and in set B, that is considered to be union. When you're talking about intersection, you're only focusing on this area, right? So this is A intersection B, and this is A union B, A union B. So when it comes to shading the regions, if they ask you to find or shade rather A intersection B, it's very easy. All you have to do is you can make some numbers, for example, 1, 2, and 3, 4, 5. And then you say, okay, so here A union B is equal to 1, 2, 3, 4, 5, right? And you can say A intersection B is equal to, what is common in both sets is actually 3. So you can say this is 3, right? So if they say shade A intersection B, it's very easy. You just have to come up with numbers like this, then you make a listing like this, and then this is 3, this is A intersection B. You can shade this region. You can shade this region. If it is A union B, you can shade both sets like that, right? But if it has to do with the complement, let's say you're talking about A union B complement. A union B complement shows that all these numbers shouldn't be shaded. So you have to shade the outside, right? If it is A intersection B complement, then you don't need to shade the intersection part, only shade these parts. But I think it will become clear as we try to deal with the math problem that we're having. So let's look at the problem that we're having. So the question is, we want to shade A union C complement intersection B. Now, to make it easier for you, you can write some numbers here. So this is 1, and we can say 2, 3, 4, 5, 6, 7, then we say 8, right? So when you look at these numbers, I think by this time you can write what A intersection B is, A intersection C is, or B intersection C, or A union B, B union C, or A union B union C, something like that. You can write that. So for example, we can say here that A intersection B is equal to the numbers that are in A and B. The numbers or the elements that are in A and B, we have 2 and 3, right? These are the numbers that are common in both sets. So 2 and 3. And we can say B intersection C, the numbers that are common in B and C. So B intersection C, the numbers that are common are 3 and 5. 3 and 5. And we can say that we can also say A intersection C. So when you look at A intersection C, the numbers that are common in both set A and C, we have 3 and 4. 3 and 4. Then we can say also A intersection B intersection C. That is the numbers that are common in all the sets. The numbers that are common in all the sets that we are having, set A, set B, and set C, it is the number at the center here, which is 3. So when it comes to union, A union B, you can just see that this is A union B. So you're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you have B union C, C union A, just like that. Or you can also have A union B union C, just like that. So I think you can do all those writings. I think it's not very difficult for you to do that. Now, when you look at the question here, let's try to analyze the question here. So according to the question here, we want to shade A union C complement intersection B. Now, it's very easy here because you just have to find out what A union C is. What is A union C? It is this region. This entire region here is A union C. The combination of set A and set C. That is A union C. But since this is complement, because these are the numbers A union C, you have 1, 2, 3, 4, and then you have 5 and 7. So these are the numbers, the elements of set A union C. But notice that it is complement. There's a complement sign here. So when we are talking about the complement of A union C, A union C complement, it means that we are not going to include these numbers because these are making up A union C. Since it is A union C complement, we're not going to include these numbers. So when we do that, the only values that we are going to remain with are these 6 here. When we're talking about the 3 sets, we're going to remain with 6 only. That's why it is also specifying here that it's not just A union C complement, but also intersection B. So include the elements that are in set B. When you include the elements that are in set B here, you have 6. And since we are not including A union C, then that's the part that we should shade. So we need to shade this part. And so this is how you shade sets like this one. So here's the second question. Use the set notation to describe the shaded region in the Venn diagram below. So I think it's very easy for you to actually get the correct answer for this one, because you notice that the part of the universal set that is shaded is the part that belongs to A. Of course, the entire A set section is not shaded, only this portion. You notice that it excludes both set B and set C. So because we are excluding set B and set C, obviously you can quickly see that B union C here is having a complement because we are not including these when we are trying to shade. It's just like the last question. It's quite similar, except that in the last question we were looking at A union C complement intersection B. Here it's just the opposite. It's B union C, then intersection A. So this is the answer that you have. Question 3. Use the set notation to describe the shaded region in the diagram below. So you notice that you have the universal set here, and you have set A, which has got 2 subsets, set B and set C. You notice that the part that is shaded is that which belongs to A, but B and C are excluded completely. So I think this is not difficult as well to actually deal with, because if you are trying to describe this shaded region, then it's talking about the elements that are not in set B and C. So obviously it's set B and C. This is the union B union C. The elements that are not here, we shade. So in other words, we're excluding B and C. This should be B union C, which is a complement. And then, just like the previous one, intersection A. So this is how you write the description of this particular set. Question 4. Use the set notation to describe the shaded region in the diagram below. Now, you will notice that this is the universal set, and we have, as usual, set A, set B, and set C. Notice that the regions that have been shaded here are part of set A and set B, and set C has been completely excluded. So that means that, as opposed to our previous questions, set C here has been excluded. It is a complement. The members of set C are not shaded, so set C is a complement. And so we're going to write now the union because we are talking about A union B. So this is A union B. So to write it in a more formal way, it's A union B intersection C complement. So this is how we write it. Question 5. Shared B complement intersection A intersection C in the Venn diagram below. Notice that we only have intersection here. So let's try to write down numbers to help us here. 1, 2, 3, 4, 5, 6, 7. So here A intersection B is going to be, so what is common in A and B? We have 2 and 3. And B intersection C, what is common is we have 3 and 6. And we also have A intersection C, where we have 3 and 4. So notice that when you look at the description here, what we have to shade, we have B complement intersection A intersection C. Notice that there is a complement here. So whatever that has to do with B shouldn't be included and therefore shouldn't be shaded. So the only thing that we are going to shade here is A intersection C without including the part of B. So for example, here A intersection C is here. This is the region 4 and 3 is A intersection C, 4 and 3. But because 3 is also in set B, 3 is also in set B, therefore 3 shouldn't be included. So these 3 shouldn't be shaded. Therefore, we are only going to shade the 4 portion or the 4 region, which is actually here. So this is how we are going to shade this particular set description.